NanoRidge was formed with a suite of licenses from Rice University dealing with nanotechnology. And there's 18 different technologies that have to do with taking nanotubes and making them so that they transfer properties to plastics and rubbers. Nanotubes are an extremely unique material. If you could take a human hair and divide it about 75,000 times in diameter, then you'd have about a nanometer. We take and modify the nanotubes that are produced and chemically etch them so that they will incorporate themselves better into a host material like a plastic or rubber. In rubber, the nanotubes impart a property that makes it a little bit more resilient to wear, and it'll do that at a higher temperature. We can modify the nanotubes so that they'll only let a limited amount of electricity go through. Well, what happens when that is the case is that they get hot. And so we can run an electric current through just a piece of plastic film, and that piece of plastic film will heat up depending on the amount of current that's put through there, and that will melt ice, or it will melt hydrates that formed inside of pipes for the gas pipelines when they have an excursion from their normal operating procedures. And of course, one of the most exciting things about that is that it would be put on an airplane or a helicopter to do ice remediation or melt ice without chemicals. So you can just put this on the wing of the airplane, reduce the weight of it by about 80% in this case from their copper mesh that they use currently, and they'll be able to put a little current through and melt it off and take off. The other place where we're actually working on currently in conjunction with companies here in Houston is on making a conductor out of nanotubes that will conduct electricity enough to power light bulbs, to power pumps, and to power, in this case, offshore platform materials or pumping of the oil wells at the bottom of the ocean. One of the funnest projects we've been involved in recently has to do with armor, for military armor, or anti-ballistic armor. And we helped start a company here in Houston that utilizes our binder material that uses nanotubes in it to help stop bullets. The neatest thing about this is that it's lightweight, it's plastic, and we put these into a regular Kevlar material, go through some top secret processes, and we're able to stop a bullet that's going faster than normal Kevlar or current technology will do. The armor that we started on working with has to do with vehicle armor for the military. Their armor weighs somewhere around 16 to 18 pounds a square foot, but what we do it with is 6-pound armor instead of 16-pound armor. The other thing is we will be growing jobs for this community. We will grow, in one of our companies, we'll grow about 35 people in the next 3 years. And depending on where the plant becomes located, there'll be an additional 350 people at the plant within about 4 to 5 years. So we are about creating jobs, about building the business, and making sure that the technology is adequately exploited, but yet enough is returned for investment into that to keep this area growing. HTC at least helped us so that we skipped a lot of the failure points. We have enjoyed very much our association with their organization, their staff, and just the general attitude that you find when you come and visit them here.